Purpose of this video is to tell you about our trip to Castles and Coasters and what we learned about Sir Isaac Newton's 3 laws and to see them in action. We went with the freshest teacher around, Mrs. Newell. Now I'll shut up right now while you guys enjoy the show, created by Garrett Perry. Newton's first law, the law of inertia, states that an object in motion tends to stay in motion while an object in rest tends to stay at rest. The skydiver here uses the first law because of its using the force of gravity and friction. Now, it wants to stay in that first spot in the ground, not fine, but the part of the ride is to bring you up and drop you down. So now it is going up. It wants to stay going up, but gravity is pushing it down, making it go stopping and slowing, but at such a small pace you can't really notice it. And then at the end, it wants to stay up at the top, but the force of gravity is pushing it down. And as it goes down, it wants to stay going down because it wants to stay in motion. But the unbalanced force of the bungee cords and the weights slows it down to a halt so the passengers can get off safely and sound. Newton's second law of motion pertains to the behavior of objects for which all existing forces are not balanced, just like the magic carpet shown here. The second law states that the acceleration of an object is dependent upon 2 variables, the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force of the acting upon the object and inversely upon the mass of the object. As the force acting on an object is increased, the acceleration of the object is increased. As the mass of an object is increased, the acceleration of the object is decreased. Newton's third law of motion. For every action there is an equal and opposite reaction. Statement means that in every interaction, these pair the forces acting on the 2 interacting objects. The size of the forces on the first object equals the size of the force on the second object. The direction of the force on the first object is opposite to the direction of the force on the second object. Force always compares equal and opposite actions to reaction force pairs.